Okay, so I wanted to kind of do a summary of the chapter and actually go through as many or all of the problems in the review for you guys, because I know a lot of you guys are getting a little frustrated and have questions and stuff, and I want to make sure that I address everything. So as I go through the review, I'm going to kind of do a little explanation with everything that we're doing. So please, and then jot down any additional questions that you have, because I want to make sure I address them. I am going to still do the test on Thursday, though. But if you do have any questions on that take-home quiz and stuff, please just let me know. I'm here to help you. Okay? So, right. So first of all, I want you guys to write down these ratios of sine, cosine, and tangent for me. And cosecant, and secant, and cotangent. Now we're used to usually using opposite over hypotenuse and stuff like that, but this is really going to be helpful for you. So I'm going to go ahead and write down the other. So remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then cosecant is just the inverse of sine. It's also known as 1 over sine, right? Cosine or secant is the inverse of cosine, or just 1 over cosine. And cotangent is the inverse of tangent. Oops, that's an O, or 1 over tangent. Okay, so also you need to remember where everything is positive. So remember I used all students take calculus as a way of helping you guys remember that all trig values are positive in the first quadrant, sine and cosecant are positive in the second quadrant, tangent and cotangent in the third, and so cosine and secant are positive in the fourth quadrant. Okay? The other thing that you guys need to know, and I'm going to write down a lot of notes in here, and I'll scan these in so you guys can print them out, whatever's helpful to you. So when we're looking at an angle, we usually go counterclockwise. So this part right here is called the initial side. And this side right here is called the terminal side. Clockwise results in positive rotations, and then counterclockwise are in negative rotations, okay? Remember, we also switch from radians to degrees, but we'll get to those. So the first thing we need to do is find the quadrant in which the terminal side of the angle appears. So I'm going through the review as I see it. So find the quadrant where the terminal side is. Now I'm going to use the unit circle a lot too, because I want to keep going back and forth to it. You are expected to memorize it, so please be careful, okay? So our first thing is 13 pi over 4. So remember, if we do one full revolution, it's 2 pi. So remember, 2 pi is equal to 360 degrees. As you can see, this is over 1 full revolution. So what we have to do is find out a coterminal angle, okay? So what happens is when we're finding coterminal angles, we add or subtract 2 pi or 360 degrees, depending on whether or not this is in radians or degrees. Well, this is in radians, so this is over 2 pi, so I'm going to subtract 2 pi. Now, here's the thing. You guys need to have a common denominator when you do this. The denominator here is 4, and the denominator here is 1. So I'm going to change this to common denominators. So this ends up being 13 pi minus 8 pi, and it's all over 4 because they're both, I'll just separate them out so you guys don't get, minus 8 pi over 4. Okay, so that gives me 5 pi over 4. Okay, now when we look at that, 5 pi over 4, that is on the unit circle. So let's take a look at that unit circle. 5 pi over 4 is right over here, 225 degrees. That's in your third quadrant. Okay, so that's in quadrant 3. All right, so I'm going to go through these step by step so everybody is comfortable and understands this. So number 2, we have negative 23 pi over 3. Well, this is negative and it's well over 2 pi, so I'm going to go ahead and add 2 pi. Once again, I need a common denominator, so I'm going to multiply this by 3 over 3. Now, I'm going to have to do it again, probably. Okay, so this is 23 pi over 3 plus 6 pi, or negative 23 pi over 3, over 3, so that's equal to negative 17 pi over 3. I'm going to keep adding 2 pi to make it positive because that's where I want to find. I want to find a coterminal angle that's in the positive thing. So I'm going to add 6 pi over 3. So that, and again, I got that from here, right? So if I'm just adding 2 pi, go back to the same thing. So this is negative 11 pi over 3. I'm going to add again, plus 6 pi over 3. So that becomes negative 5 pi over 3. And then finally, I'm going to add 6 pi over 3, and I just get pi over 3, which is 60 degrees, which is in quadrant 1. Okay? So what I would strongly suggest you do for each one of these problems is write out every step that you did, okay? Now, number 3 is easy. We've got 268 degrees. Well, if we look at our unit circle, this is 270 degrees right here, so it's over here. So this is in the third quadrant. So this is this beautiful one in the third quadrant. Now what happens to 375? Well, so if we have negative 375 degrees, I'm going to keep adding 360 to it until I make it positive. So negative 375 plus 360 is negative 15. And then I'm going to add 360 again. And that gives me 345. And that is in quadrant 4. Okay, so that's why we use these coterminal angles and stuff, because we want to find out which quadrant it's in, where it terminates. So that's how we find coterminal angles. We either add or subtract 2 pi or 360. So that's numbers 1 through 4 for you. So let me go to number 5 and 6. Now 5 and 6, I'm going to go ahead and take some, draw some pictures for you guys just to make it easier for you. So for number 5, we want to say where these quadrants lie in the following positions. So tangent of theta here is greater than 0. So that just tells me that tangent is positive. And sine is less than 0. So sine is negative. So let's go ahead and draw our little coordinate plane. So all students take calculus. So this is 1, 2, 3, and 4. Okay, so we want to know where tangent is positive. First of all, tangent is positive here and here. So these are the possibilities. So I'll go ahead and label those with a different color just so you guys can see this. So tangent is positive here and here. Now, we want to know where sine is negative. So sine is not negative here, not negative here. It's negative here and negative here. So we want to find the place where they're both, it satisfies both of those. So that's in quadrant 3. Okay. Now let's look at number 6. Here we have the cosecant of theta is greater than 0. So remember, we have to remember that sine. That relates to sine. Okay. And then cotangent of theta is greater than 0. So that also relates to tangent. All right. So let's look. So where is cosecant positive? Cosecant is positive here and here. And then tangent is positive, or cotangent, I'm sorry. Cotangent is positive here and here. So where does that meet both possible qualifications? That would be in the first quadrant. So that's quadrant 1. Okay, let's look at 7 and 8. Theta is an angle. Sorry. Theta is an angle such that it's in between 0 and 2 pi. So it's in this cute little 360 degrees. All right. And if any, for what values of theta make the following undefined. Okay. Okay, so this is where we have to look. We're looking at number 7. We're trying to see where it is undefined. So tangent of theta. Okay, so remember, let's look at these. We'll look at our unit circle here. So remember, tangent of theta is sine over cosine, or what's easier to do is y over x, right? It's equal to sine over cosine. So when is something undefined? Something is undefined when you divide by 0. So undefined okay, so really on the unit circle, the only ones that can really be undefined are tangent, cotangent, secant, and cosecant, because we always have positive values for sine and cosine, or 0. Okay, so here, Tangent is, so we want to see where is cosine equal to 0. So let's remember that cosine is x and sine is y, right? When we're doing our unit circle. And if we look here, our x values here are 0, 1, and 0, -1. Okay? And so for what values is cosine 0? So that tells me at pi over 2, and then if I go down, and that's 3 pi over 2 at the bottom of my thing. So tangent is undefined when cosine is equal to 0, and those values are pi over 2 and 3 pi over 2. Okay? The other one is asking when is cosine undefined, and it's never undefined. Okay. So next thing we do from 9 through 14 is we're converting from degrees to radians, okay? And I'm going to walk you through some of those calculator tricks as well so that you guys can, just practice some of that too. So remember when we're doing, 9 through 11, we're converting degrees to radians. So remember, you multiply by pi over 180, okay? And you want to make sure you reduce it as well. So let's start off at 9. So 9 is equal to 65 degrees. So I'm going to do 65 times pi over 180. So one of the things that I tell you guys to do is to go ahead and take your calculator. And remember how I always say just ignore pi. It's used as a variable right now. So I'm going to do 65 times, and I'm going to do alpha y equals 1 over 180. Okay, so that's 13 over 36. So that ends up being 13 pi over 36. Okay? Now you can multiply these and reduce them yourself. It's fine. But sometimes I try to give you guys some help. When you're converting from degrees to radians, you can use your calculator. So there is one whole section in the test that you cannot use your calculator at all. So definitely be careful of that. So convert 188. So I'm going to multiply that by pi over 180. And what's nice is that this just goes ahead and reduces it for me. Okay, and that's 47 over 45. So that's going to be 47 pi over 45, number 11. Oh, we've got 0.32, I'm sorry, I'm switching around. Number 11 is negative 232 degrees. You can keep this negative, okay? So I'm going to multiply that by pi over 180. So I've got negative 232 times, alpha y equals 1 over 180. And just stick that pi in there. So that's going to be negative 58 pi divided by 45. Okay. So hopefully that's relatively easy. Now let's go back to 12 to 14. We're going to convert from radians to degrees. Okay. one out for you. Again, these are all the problems from the review. So hopefully these are helping a little bit. Okay. So the next thing we're going to do is convert for 12 through 14. We're going to go from radians to degrees. And what we do is we just multiply by the inverse, which is 180 over pi, okay? And what's nice is that pi just goes away, okay? So let's take this one. Number 12 is 13 pi over 4. So I multiply by 180 over pi. And I just cancel out those pi's. And I'm going to do alpha y equals, I'm going to do 13 over 4 times 180. And that reduces it to 585 degrees. So let's look at number 13. I've got negative 28 pi over 3 is multiplied by 180 over pi. So I'm going to go ahead and cancel these out. And again, these can be negative. So I'm going to do alpha y equals negative 28 divided by 3. And I'm multiplying that by 180. And that gives me negative 1,680 degrees. Okay, and then let's do the final one, 14. We have 0.32 pi times 180 over pi. So I go ahead and cancel that out, and I just do 180 times 0.32, and that gives me 57.6 degrees. All right, so that's number 1 through 14 for you. I know that those are probably the easiest parts of the question, but I wanted to review stuff like where things are positive and stuff like that, because I think it's going to help us as we go further. Okay, so I'm going to stop on 1 through 14. I'll start another video for you to go through 22 through 35 if I can get it, or 24 through 35 if it doesn't take too long, and then we'll go from there. Okay.